In this video, you're going to learn how to use this square boxes. And you got a box here, 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 and you'll also learn what is all these arrows about. Why this arrow, one is up and one is down, and why there are three boxes here. And if you look down here, why there are, so you got under 3D you got 1, 2, 3, 4, 5. Why there are 5 boxes here? Why there are 3 boxes in under this 3P, and so on? Why there is only one box in this 3S? So you already know these things. In fact, now in my last video I mentioned about orbitals. So what's an orbital? How to define orbital? It's a region. It's a region where we can find electrons. And this region is around the nucleus. So there's s orbital. There's only one s orbital, and there are 3 p orbitals. So you can say that p is the subshell. It has got 3 p orbitals, and the name of the p orbitals are px, py, and pz, because they're in 3 different axes. And you know that in d subshell there are 5 orbitals, and there is no naming like you do your px, p, and py. Just say there are 5 orbitals. And we also know that in an orbital there can be a maximum of 2 electrons. Okay. So a square, what you see here, this box what you see here, so this box means an orbital. It is just one orbital. Okay. Now if you apply this knowledge now, you know what exactly these boxes are. So look at this first one. This is a S subshell in the shell number 1. So for the timing, forget about these shell numbers. Okay, you know what these shell numbers are. Okay, so this is shell 2, this is the 3rd shell, and this is the 4th shell. Okay, so there is only one s orbital. So and an orbital can also be shown as a square, like this empty square. So under the S there is only one square. So there's S, you got one square, and you got, if you see here under this 3S, S is the subshell, 3 is where the subshell is, but still it's a S subshell. Under the S subshell there's only one orbital, so you find only one box here. Under P, there are 3 subshells in P, so you find 3 boxes. Likewise, in the D there are 5 orbitals. Sorry, there are 5 orbitals in D, or there are 5 d orbitals, so there are 5 boxes. So next is about an arrow. So an arrow, this arrow, whether it's up or down, so these arrows, they represent electron. There is a single electron. It can be up or it can be down. Again, this is electron. Now when you see 2 electrons in the orbital, an orbital can have maximum 2 electron. See here you got an orbital which has got only 1 electron, and here you got orbital the 2 electrons. So whenever 2 electrons get into a single orbital, these 2 electrons are entering this orbital, they always spin in opposite direction. You're going to learn in physics why they spin in opposite direction. So they're going to nullify the momentum. So if one electron rotates in clockwise, so the anti-clockwise, the other electron will rotate in anti-clockwise. So either way, yeah, the anti-clockwise. Okay, so that is the reason why you show electron using 2 different arrows. So keep in mind, so whenever an electron enters an orbital, so here you got an orbital. Now we know that orbital is a rectangle. You don't have to show orbital in the shape of the sphere, or you don't have to show in the space of a dumbbell, or you got a donut thing. Okay, don't have to use these type of things. Okay, just use a empty box to show, oh, this is an orbital. It can have maximum of 2 electrons. So that's all. Now when you show the first electron, so here for hydrogen, for example, hydrogen has got only 1 electron, and that electron happens to be in the s orbital of the main, in the shell 1. So when the first electron enters this orbital, you show as an arrow, up arrow. Remember, an arrow is a single electron. You can either start from here, or you can also show that as a down arrow. But you can never have 2 electron either both in the down arrow, or you cannot have 2 in this up arrow. So this is wrong, because remember, 2 electron can exist in the orbital only if they spin in opposite direction. The net momentum, so one going this way, other going this way, so the net momentum should be 0. Okay, that's what the arrow is all about. Okay, so don't try to do these things. Okay, you can't use both down arrow and up arrow. So when you write the electron configuration, say for example hydrogen, you write 1s1. But if they ask you show the spin of the electron, so what you have to do is you have to first show the orbital, and this one electron you can show as a up arrow. Next is your next is for helium. So helium has got 2 electrons, and both electrons are in the s orbital. You write like this way. But if you have to show that with the spin of electron, so this is the first electron, this is the second electron, like this way. And next is the lithium. So lithium has got 3 electrons. You got 1s2 and 2s1. So usually whenever you show these electrons, sorry, forget about that. Okay, so how do you show this thing? Okay, now you know that lithium is 1s2, 2s1. Okay, so this is the s orbital of shell 1. This is the s orbital of 1s orbital of shell 2. Now the shell 1 is complete, so you show there as 2 electrons, 1 up and 1 down. Whereas in shell 2 there is only 1 electron in s orbital, show that as 1 arrow. Next is the beryllium. So beryllium is 1s2 and 2s2. So there is nothing in the p orbitals. So this you're going to show as the 2 electrons s orbital, this and that, and here there are 2 more electrons in s orbital second shell, up arrow, down arrow, that's it. So after that, so next is the boron. So boron has got 5 electrons, so that will be 1s1, 2s2, sorry, 1s2, okay, 2s2 and 2p1. You know there are 3 orbitals in p subshell. Otherwise there are p, so there are 3 p orbitals. So first you have to show all the orbitals. So this is the 1 orbital, s orbital of the first shell. This is the s orbital. There's only 1 s orbital. There are 3 p orbitals. So you have to show all the 3 orbitals here. Okay. Now 2 electrons go here. 2 electrons will go here. Now out of these 3 p orbitals, there is only 1 electron you have here. So that will go into the very first p orbital. So there are no electrons in these two p orbitals. Now go with the carbon. So carbon is just one electron more than boron, so it will be looking like that. It will be like this way. So you do the same thing. So you show all the three, yeah. Now there's a trick here, that's what remember. So you go here, this is fine, and the 2 electrons here. Now you cannot put 2 electrons here. So it makes, you think that what you need is, you need only 2 electrons in the p subshell. So see this, it is 1s2, 2s2 and 2p2. Okay, now the way the electron goes is, they don't just jump into the existing orbital. So what electron does is something, it probably does something clever. It always try to go into a space where there is no repulsion. So here what we got is already, okay, if you think about carbon, so already the first p orbital has got a electron. Now a new electron, okay, electron which is going to go in this in the same p subshell, it sees there is already one electron here, because 2 electrons, they have the same negative sign, they try to repel each other. So it always try to go to a place where there is no obstruction. So this new electron will go here. So that is why you can see here the 2 electrons in the p shell are one here, one there. It is never, you can't put both here, because the logic is electron always try to get into a place where there is no repulsion or where there is no obstruction. So for next one, nitrogen. So nitrogen, there are 3 electrons in the p shell. So the nitrogen, the next electron into nitrogen, it doesn't like this, it doesn't like that, it doesn't like that. Okay, it says there's one p orbital, nothing is there, it will go and occupy the p orbital. Okay, now this repeats. So there is a general rule. Okay, just like sorting the numbers, each electron will occupy a separate orbital or a different orbital. Now when there is no empty orbital, they go and join with the existing one. Take for example oxygen. In oxygen there are 4 electrons in the p shell. So you got a new electron for oxygen. Okay, a new oxygen. So it says all 3 p orbitals are already occupied by the electron. It will go and join the first one. Yeah. In some book, they write like this way. It doesn't matter, because okay, there's no difference between these 3 p orbitals. Some book they write like this way. Assume that already there are single electron in all the p orbitals, like this way. The next one electron they can also put here. So both are same, this and this are same. You can follow whichever method. I would go with the first approach, because we always write from left to right. Okay, so one thing what you have to remember is, there is no difference between the 3 orbitals. They are all identical. Okay, we just don't know. We can say that all 3 p orbitals are the same distance from the nucleus. We cannot say px is near, py is further, or pz is further. You can't say that. Okay, so for that reason you can either use this or this. Both are valid. So I'm going to walk you through this table now. So look at the beryllium. It has got 1 electron. It has got 1 electron in the p shell. So it occupies this. Remember, there are 3 p orbitals. So this 1 electron takes the position here. For carbon, the next electron will occupy the next empty p orbital. For nitrogen, it occupies the next empty one. So all this, you see the way I speak here, all these 3 p orbitals have got single electrons. Okay, so only when all these p orbitals are occupied, okay, the next electron, okay, will go into the first one, existing one. Again, don't forget to put this down arrow. Remember, two electrons can reside together, stay together only when they rotate in opposite direction. The word used is called spin. You're going to learn this, in detail in the first chapter of physics, spinning. Okay, so the electrons spin in opposite direction because the total angular momentum must be zero. Angular momentum must be zero. Okay, this is the reason I have to give. Got it? So here, so next one is the next electron. If you compare this here, okay, this is occupied. You know that an orbital can have only two electrons. The next electron will join this one. So this is empty space here. It occupies that. Now for neon, so the only place it can go is over here. So it occupies there. Okay. And then for sodium, sodium has to go to the third shell. It has to go to 3s. So sodium has gone into 1. There's up arrow, 1 electron here. Next Mg, 2 electrons. So the next electron will go here only. Next, this repeats for the, just like it repeated here. It again, it's the same theory here. The first electron into the p shell. See the way to describe that. The first electron in the p shell. The first electron p shell occupies this, the first orbital. There are 3 p orbitals. The second electron in the p shell occupies the second orbit. The third electron occupies this. So here all the three orbitals have got 1 electron each. Here you can also say that there are 2 orbitals that are free, 1 orbital is free. You can use these type of words to speak about this electron configurations. Now here we need 4 electrons in the p shell. So you got 2 here, 1 and 1. Okay. So the one extra electron has to go here. The 5th electron will pair with the existing one here. You got that. The 6th electron will go pair up here. Okay. Now start from SC. This is where the D shell will start filling. There are 5 orbitals of type D, or you can say there are 5 d orbitals. Okay, so that's the reason why there are 5 boxes, and each orbital can take 2 electrons. Okay, see, this is the first electron in the d shell, so it occupies this space. The next one requires 2 electrons in the d shell, so it doesn't go into the existing one. Remember, this is wrong. It doesn't go here. It occupies a empty orbital. It occupies that. The third occupies the third free orbital. The fourth one, this I think they missed one. Okay, there's something which we're going to discuss later, why it has gone here. Okay, don't worry too much about that, because all these are come under the transition elements. They're a bit they have got different properties though. Now look at here, it says there are 5 electrons in the d subshell. So d already has got 5 orbitals, so these 5 electrons will go into the separate orbitals. Now the 6th one, the 6th electron in the d shell, so there are no free orbitals, so it will go and spin in a reverse direction and joins here. And the 7th one will join the next orbital. 8th one again joins with the opposite spin. 9th opposite spin. 10th opposite spin. Okay, so there altogether there are 10 electrons. And now we know that. Okay, now we know a box represents an orbital. An orbital can have 2 electrons. An electron will always try to occupy a separate orbital which is empty. Now when you show electron orbital, you always use an arrow. When you show 2 electrons, you show with a different direction. Either it can be like that or it can be like this way. Okay, so I think you understood this one.